of A to B, therefore the ratio of A to B is equal to this have a damage here. So you sit at the end. Sit at the end. You sit at the end. Come right to the end. Right. Good. Therefore, the ratio of A to B is equal to A colon B. A to B is equal to A colon B. That's the ratio. That's how we represent ratio. And that is equal to A over B. That is equal to A over B. Now we're going to do example. So you write example. A cricket club has 50 members. A cricket club has 50 members, of which 28 are female. Of which 28 are female. Oh, you hear me? Oh, okay. Okay. A cricket club has 50 members, of which 28 are female. Full stop. The ratio of female members to total members is 28 to 50. Is 28 to 50. The ratio of female members to total number of members is 28 to 50. Like how I have it on the board here, 28 to 50. Or 28 over 50. Or 28 over 50. Which would be equal to 14 over 25. Which would be equal to 14 over 25. Or 14 to 25. Full stop. Find the ratio of male to female members. Find the ratio, that's the question. Find the ratio of male to female members. Find the ratio of male to female members. Full stop. This can be found by first finding the number of males in the club. This can be found by first finding the number of males in the club and dividing this figure by the number of females. This can be found by first finding the number of males in the club and dividing this figure by the number of females. Full stop. the number of males is equal to number of males equal to 50 minus 28. Number of males is equal to 50 minus 28, which is equal to 22. Right? So there are 22 males in the club. Therefore, the ratio that we're looking for, which is the ratio of males to females, is equal to the number of males, which is 22, divided by the number of females, which is 28. So 22 over 28. But normally we don't leave it in this form because these two numbers, the numerator and the denominator, have common factors, or they have a common factor. And the common factor in this case is 2. So 2 into 22 will give me 11, and 2 into 28 will give me 14. So therefore, this 22 over 28 could be reduced to 11 over 14. 11 over 14. And this could be expressed as 11 colon 14, which means 11 to 14. Okay, that's another way of expressing that ratio. Any questions so far? That clear, right? Okay. We're going to do a second example now. Second example. This was one where I more or less dictated everything. This one will have more wording in it now. So, example 2. Express 3 meters to 175 centimeters as a fraction in its lowest terms. Express 3 meters to 175 centimeters as a fraction in its lowest terms. Now initially, if you look at that question, you may be tempted to take 3 and divide it by 175. Right? Because ratio means put the first item over the second item. Like here, ratio of males to females, put the 22 over the 28, and then divide throughout until you can't go any further. So you would maybe tempted to put the 3 meters over the 175 and divide until you can't go any further, not so? You're not tempted to do that. Okay, what do you think you should do? All right. Okay, well, the first thing you have to do is to ensure that the two items are in the same units. What you have presently is that one is in meters and one is in centimeters. Okay? So you have to first convert either the 3 meters to centimeters or the 175 centimeters to meters. All right? So if I want to express 3 meters to 175 centimeters, what I'd have to do is convert this. I'm choosing to convert the meters to centimeters. How many centimeters are there in a meter? Correct. You're supposed to know that. You're supposed to know that there are 100 centimeters in 1 meter. All right? What you're supposed to know as well is how many millimeters there are in 1 meter. How many are there? 1,000. What you are supposed to also know, as we are on the topic, is how many meters there are in a kilometer. Can anybody tell me how many meters there are in a kilometer? 1,000. Very good. There are 1,000 meters in a kilometer. And from these three, you're supposed to be able to move from one to the other. How many centimeters in a kilometer? How many millimeters in a kilometer? And so on. Right? So you can take those notes there. To take those notes there. But what we have to do now in our question is convert the meters to centimeters or convert centimeters to meters. I will choose to convert meters to centimeters. So I will convert this by saying 3 meters is the same thing as 3 times 100 centimeters. Because there are 100 centimeters in each meter. So for 3 of them, you have to multiply it by 3. So this becomes 300 centimeters to 175 centimeters. Like that. And if you want to express that as a ratio, it will be, if I want to express that as a ratio, it will be 300 over 175. Because if we review what they asked us to do, they said to express 3 meters to 175 centimeters as a fraction in its lowest terms. Is this fraction in its lowest term currently? This fraction here, is it in its lowest term currently? No. What is a common factor of 300 and 175? 5. Anything else? Something larger. Not 10, but 25, because 10 will leave a remainder in the bottom one. But 25 is a good one. 25 will go into 300 how many times? How many people work in parlor? How many 25 cents make up $3? 12. That's how you could think about it. How many 25 cents make up $1.75? 4 and 3? 7. Right? You don't have to divide by 25 per se. You have to use things that help you relate to it. Okay? And are there any more common factors again? Can I divide 12 and 7 by any common factor? No. So therefore, I have reduced the ratio to a fraction in its lowest terms. Okay? Any questions? Fidel, anything? Good so far? All right. Okay, so take it down quickly. If you haven't, because we're going on, I'm going to give you a question now to try. Okay, so the question I'm giving you to try is this. Express 30 kilometers to 10 meters. Express 30 kilometers to 10 meters as a fraction in its lowest term. Express 30 kilometers to 10 meters as a fraction in its lowest term. Okay, so try that for me now. Okay, so we have to express 30 kilometers to 10 meters as a fraction in its lowest terms. But if you observe this unit and this unit, different. Kilometers is different to meters. So we have to do a conversion. Now, we know that there are 1,000 meters in 1 kilometer. 1,000 meters in 1 kilometer, right? This is 1 kilometer here. So we'd have to convert the kilometers to meters first. So 30 kilometers is the same thing as 30 multiplied by 1,000, right? And when we multiply that out, we'll get the answer in meters. Because each one of those 30 kilometers is equivalent to 1,000 meters. So 30 of them will be 30 times 1,000 meters. To 10 meters. So now, both of them are in the same unit, that'll be in meters. So this will be 30 by 1,000, 30,000. right? 2 is interpreted as a division, 10. So 30,000 meters over 10 meters, correct? Now what happens? 10 into 10, 1. 10 into 30,000 is 3,000. Meters cancel out with meters, right? So your answer would be 3,000 over 1. You cannot leave out the over 1 because they want as a fraction. A fraction must have a numerator and a denominator. So if you wrote 3,000, it wouldn't be correct. It has to be 3,000 over 1. Sorry? No, it wouldn't be correct because that's not a fraction. That's a representation of ratio, which if they just say express it as a ratio, it would be correct. But if they say express it as a fraction, first of all, it must be a numerator and a denominator. And then secondly, if they say in its lowest terms, then you have to look for common factors and divide throughout. Right. The question is why you cross out the meters? Because you have to determine what is the unit of this if there's a unit. Now in ratios of this type, they always end up with no units because you have to convert it to the same unit. So I'm just showing you why it ends up with no unit, because the units on top cancel with the units below. So the meters cancel with the meters. So we have what is known as a dimensionless ratio. Ratios in these cases are always dimensionless, right? They will have no units. Because I saw somebody give me an answer as 3,000 meters as the answer, right? But that wouldn't be the answer because they have no units in this ratio, okay? The answer is 3,000 to 1. Good? All right, so we're going on. We're going to do our next example. Is example 3. And example 3, you could put in brackets next to it the unitary method. Example 3, the unitary method. Okay, so you write in, a sum of money is to be divided among, Yari, which is Y-A-R-I, Yari, Anna, A-N-N-A, Yari, Anna, and Maria. A sum of money is to be divided among Yari, Anna, and Maria in the ratio 4 to 7 to 9. In the ratio 4 to 7 to 9. Full stop. 4 to 7 to 9. Full stop. If Anna's share amounts to $1,295, if Anna's share amounts to $1,295, calculate first one, the total sum of money to be shared. Calculate 1, the total sum of money to be shared. 2, Yari's share. 2, Yari's share. 3, the percentage of the total amount that Maria receives. So the first one is the total sum of money to be shared. The first one is the total sum of money to be shared. The second one is Yari's share. And the third question is the percentage of the total amount that Maria receives. The percentage of the total amount that Maria receives. A good way to start these questions is by writing this statement. Ratio of division. Ratio of division between the three parties. One party is Yari. The next person was Anna. And the next person was Maria. Right? Those are the three parties. So Yari to Anna to Maria is the ratio that they gave us, which is 4 to 7 to 9. 4 to 7 to 9. That's the ratio of division. Okay? Now, seeing that they want to find the total sum of money to be shared, let us find out what is the total shares. Let us find out what is the total shares in this question. Right? So we write it down. The total shares. The total shares is equal to 4 plus 7 plus 9. 4 plus 7 plus 9. 4 and 7 is 11. 11 and 9, 20. So the total shares is 20. Total shares is 20. Now, what information do we have? They told us that Anna share amount to $12.95. But if you observe here, Anna has 7 shares. Not so? Out of that 20 shares, Anna has 7 shares. So therefore, combining those two things, therefore we could say that 7 shares, which is Anna's proportion or Anna's share, was equal to the amount they gave you in the question, which was $1,295. Not so? Anna's share is $1,295. So from here, we could find what one share is. We could find what one share is, or 1 unit, or 1 part. Hence the name of this technique, which is known as a unitary method, meaning we find in 1 unit. So 1 share would be equal to $1,295 divided by 7. Okay? And that would be equal to, in this case, it's easy to work it out. When you work it out, you get $185. $185. Why is that important? Because now, to answer the first part, right, this will be answering the first part of the question, part 1. In order to get the total sum of money to be shared, will be equal to, total sum of money to be shared, will be equal to the total number of shares, which is 20, times whatever the value of 1 share is. What's 1 share? 185. 1 share is 185. So therefore, the total sum of money to be shared, which is 20 shares, will be 20 multiplied by $185. And that will work out to be, when you calculate that, that will be $3,700. Any questions there so far? Making sense? So unitary method means take the information you have, find out how much 1 share would be, and then from there now work on the other items that they want. In this case, the total sum of money to be shared was found by taking the total number of shares, which is 20, and multiplying by what 1 share is, which is $185. The second part of the question asks us to find Yari's share. But we know Yari's share from the above information, Yari's share was 4 shares. So Yari's share in terms of dollars will be 4 shares times what's the value of 1 share? 185. So just put that into your working. 4 shares times 185 would work out to be $740. Okay, so that would answer that part. Yari's share would work out to be $740. And then we look at the third part now. The third part said, find the percentage of the total amount that Maria receives. The percentage of the total amount that Maria receives. Anytime you have to find percentage, it is always best to find the fraction first. So find the fraction of the total amount that Maria receives, and then convert it to a percentage by multiplying by 100. Multiply by 100 to convert a fraction to a percentage. So therefore, let us look at the fraction part of it first. And I could say that Maria receives, how many shares did Maria receive? 9. So Maria receives 9 shares out of how many total shares? 20. So she receives 9 out of 20 shares. That is 9 over 20, or 9/20ths. Right? She received 9/20ths. And if we express this as a percentage, then we could say it'll be 9 over 20 multiplied by 100. 20 to 21, 20 into 100 is 5. 5 by 9 is 45. So you get 45%. So the percentage of the total amount that Maria receives is 45%. All right, there's another way you could do it too. You could find out how much Maria received by multiplying the 9 by 185, dividing that by the total, which was 3,700, and then multiplying the answer by 100 to get a percentage as well. In other words, you could use the dollar values and get the answer just as we had used the shares. But I prefer to use the shares because I didn't have to do any extra multiplication. I just took the 9 shares, divided by the total, and multiplied by 100. All right, those are easier way I found. Okay, so I'm going to give you one to look at now. Right? And it goes like this. A sum of money was to be shared among 3 friends. A sum of money was to be shared among 3 friends. Albert, Bruce, and Christine. A sum of money was to be shared among 3 friends. Albert, Bruce, and Christine. In the ratio 3 to 7 to 10. In the ratio 3 to 7 to 10. Full stop. If Christine received $495, if Christine received $495 more than Bruce, if Christine received $495 more than Bruce, find the sum of money shared. Find the sum of money shared. Find the sum of money shared. Okay, so look at that. See what you come up with. Take about 3 minutes just to get an idea of what you think you would do. Right? And then we'll do it on the board. Okay, so I started it up here. The ratio of division is 3 to 7 to 10. 3 to 7 to 10. The total number of parts shared, therefore, will be the sum of those three. When you add up the 3, the 7, and the 10. 3 plus 7 plus 10 will give me 20. Now, Christine received 10 shares. Christine received 10 shares. And Bruce received 7 shares. So therefore, Christine received 3 more shares than Bruce. How I got that? Take 10 minus 7 will give me 3. So she received 3 shares more than Bruce. That was the critical point in this question, because they told us Christine received $495 more than Bruce. That's all? So English is important here. So if she received $495 more than Bruce, and you know that she received 3 shares more than Bruce, then we could infer that 3 shares must be equal to how much? $495. $495. That must be what is equivalent to. So therefore, if 3 shares is $495, then that would imply that 1 share is equal to $495 divided by 3. And $495 divided by 3, if you work it out, is $165. But why is it important to find 1 share? If we find 1 share, we could answer the question, which is the sum of money shared. To get the sum of money shared, therefore, sum of money shared would be equal to whatever the total amount to be shared, which is 20, by what 1 share is. So it would be 20 multiplied by $165. Okay, so that'll give you the sum of money to be shared. And when you work that out, you'll get $3,300. $3,300. Any questions there? Read it through. Make sure you're grasping what we're doing there. Okay? Write it down. Make sure you have it so that if in the event that you don't grasp it, you could still ask a question about it when you get the opportunity. Okay? You're writing, if 2 quantities are in direct proportion, then they increase or decrease by the same ratio. Then they increase or decrease by the same ratio. That is, if one quantity is doubled, the other is also doubled. That is, if one quantity is doubled, the other is also doubled. Now what I'm going to put up on the board now is the mathematical reasoning behind the equations we'll be using. You don't really have to know the mathematical reasoning per se, but you have to know how to use the equations. Okay? So it basically goes like this. If y is proportional to x, right? If y is proportional to x, this could be written mathematically as right? This sign here means proportional. That's the way you write proportional in mathematics. But the proportional sign in mathematics, if we want to replace the proportional sign by an equal sign, because we are accustomed to working with equations, right? How do we replace the proportional sign by an equal sign? We have to put equal to and a constant k multiplied by x. If two quantities are proportional, then it means that one quantity, in this case y, is equal to a constant times the other quantity. Right? That is what it means in mathematics. But we'll elaborate on it a little further in a little while. But from this, we could deduce something else. We could deduce that y over x will be equal to k. How did I do that? I divided on the right hand side by x, and I divided on the left hand side by x. So I ended up with y over x is equal to k. If I divide the right hand side by x, the x will cancel to give me k. If I divide the left hand side by x, it will look like this, y divided by x. And from there, if y over x is equal to k, that implies that y1 over x1 is equal to y2 over x2. y1 over x1 is equal to y2 over x2. Or x1 over y1 is equal to x2 over y2. And this equation here is what we'll be using to solve these problems. Right? So anytime we determine that two quantities are proportional, then this is the relationship we'll be using to solve it. So if y is proportional to x, we'll use this. x1 over y1 is equal to x2 over y2. And I'll give you an example on how we use it now and the next step. Okay? This is what you really have to know. If something is proportional, y is proportional to x, you have to know this relationship. And we'll see how it works now in the example that I'll give you. Okay? So the example is as follows. Okay, take down that and then I'll give you the example. Let me give you. Okay, the example is a car travels 180 kilometers. A car travels 180 kilometers on 6 liters of petrol. A car travels 180 kilometers on 6 liters of petrol. Full stop. How many liters of petrol? How many liters of petrol will be needed? How many liters of petrol will be needed to complete a journey of 540 kilometers? To complete a journey of 540 kilometers. Okay, so let's write it down in a simple way. 180 kilometers is the distance covered by 6 liters of petrol. Okay? 180 kilometers is the distance covered by 6 liters of petrol. They are asking us how many liters of petrol will be needed to complete a journey of 540 kilometers. So for 540 kilometers, they are asking us what is required to do that. Okay? Now in an exam, they would not tell you that this is direct proportion. They will put it to you and you'll have to determine if it is direct proportion or indirect proportion. There are two types. In direct proportion, we have to look to see if one quantity behaves in a particular way, if the other quantity behaves in that way as well. In other words, if I call this quantity here x, x refers to the distance traveled, and I call this quantity on the right hand side y, which refers to the liters of petrol used, then we have to ask ourselves this question. If it takes 180 kilometers, if it takes 6 liters to travel 180 kilometers, if we have to travel a greater distance, 540 kilometers, will the amount of liters required go up or go down? It will go up. So what we are saying is when x goes up, y also goes up. There are some instances when this quantity goes up, the other one would go down. And that would be indirect proportion. In this case, this is direct proportion because we know that when the number of kilometers to be traveled goes up, the number of liters required to do that journey also goes up. Right? Also goes up. So we know that this is direct proportion. In indirect proportion, the behavior is reversed, and we'll do an example just now. So whenever we establish that it is direct proportion, we know we have to use the equation x1 over y1 is equal to x2 over y2, which is what we just learned. But in your mind, you saying, yes, sir, we know that. But what is x1, what is y1, what is x2, and what is y2, not so? You want to know what is all of that? It's very easy. Because we already established that this column here is x1. Is x, sorry. x1 will be the first x that was mentioned in the question. So if you read back your question, which one was mentioned first, the 180 or the 540? 180. So that is x1. 540 was mentioned secondly, right? So that will be x2. In terms of the y quantities or the number of liters of petrol required, which one was mentioned first? 6 liters. So that will be y1. And then the one that is missing is the one that you want to find, and that will be y2. Good? So we now know what x1 is, and what x2 is, what y1 is, and what y2 is. So it becomes a simple case of substituting now into this equation. Okay? So let's substitute the values. x1 will be 180 over y1 will be 6 is equal to x2, which is 540 over y2, which is unknown. So we put back y2 like that. So what happens then? We learn something called cross multiplication. It says that if we multiply 540 by 6, we could put it equal to 180 by y2 when we did solving equations. So I could write, from here, I could come up here and write 180 multiplied by y2 must be equal to 540 multiplied by 6. When we did solving equations, that is one process we had learned when we were doing solving equations when the both sides were fractional like this. So then from here, I could get that y2 is equal to 540 multiplied by 6 divided by what? 180, because I divide this side by 180, I get y2. And I must also do the same thing on this side to maintain equality. So therefore, I end up with y2 is equal to 540 by 6 over 180. And if you work out what that is, you will get 18 liters. So this works out to be 18, and you have to put in the unit of liters. Does that make sense? We expected that it should go up, right? It should go up. But what is interesting is if you look at 180 and 540, you'd realize that this is 3 times that. Not so? So that means that this should go up 3 times. 3 times 6 is 18. Okay? But the trick about it is, it's not always in that easy ratio that you could see. So you have to have a method that you could work it out all the time. And the method is determine if it's direct proportion. If it is, x1 over y1 equal to x2 over y2. Substitute and solve the equation. You all know how to solve all the different types of equations, so that shouldn't be a problem for you at all. That shouldn't be a problem for you at all. Okay? Okay, the next example, the next topic will be inverse or indirect proportion. Next topic, inverse or indirect proportion. Inverse or indirect proportion. If two quantities are inversely proportional, then one quantity changes by the inverse ratio. If two quantities are inversely proportional, then one quantity changes by the inverse ratio or reciprocal ratio of the other quantity. That is, i.e., if the first quantity is doubled, open brackets, open brackets, multiply by 2 or times 2, close brackets, multiply by 2, close brackets, then the second quantity is halved. Halved is spelled H-A-L-V-E-D. Halved. Open brackets, multiplied by a half, or 1 over 2. Close brackets. Then the second quantity is halved. Open brackets, multiplied by 1 over 2 or half. Close brackets. i.e., open brackets, a half is the reciprocal of 2. Open brackets, a half is the reciprocal of 2. Close brackets. The mathematical reasoning for the equation, I'll write it on the board. And it goes like, if y is inversely proportional to x, what it means is this. Y is proportional to 1 over x. Inversely proportional to x means that y is proportional to 1 over x. That's what it translates to mathematically. Which means that y is equal to some constant multiplied by 1 over x. Because remember, the proportional sign means replaced by equal sign and a constant. So this here means that y over 1, y is the same thing as y over 1, is equal to k times 1 on top is k over x. And if we cross multiply in this case, we'll get x, y is equal to k when you cross multiply. X by y is equal to k by 1, so xy equal to k, and that implies that x1, y1 is equal to x2, y2. So this here, what I did there was the mathematical reasoning behind the formula. But the formula that you really have to know is the one that I'm pointing out to you at the bottom. So what we're saying is, if we know y is inversely proportional to x, as I'll show you how to determine, then this is the equation we'll use. x1, y1 is equal to x2, y2. If it is directly proportional, then we know x1 over y1 is equal to x2 over y2, like what we just did before. But if we determine that it is inversely proportional, then we use x1, y1 equal to x2, y2. All right? So now, I'll ask you a quick question on this side here. And the question goes like this. If 10 men could build a house, right? These 10 men could build a house in 20 days. My question to you is, how long will it take 20 men to build that same house? How long will it take them? Somebody tell me. 10 days? Not 40 days, right? Right. So what you are telling me is when the number of men go up, the time to do the job goes down. So therefore, this is an example of inverse proportion. In direct proportion that we had done before, when the distance traveled went up, the amount of liters to do the journey also went up, not so? But in this example, in this particular question, what is happening here is when the number of men required to do the job goes up, the time to do the job would go down. But not only does it go down, it goes down by a particular proportion. What you guys told me is that it would take how much days? 10 days. So what you did, you didn't just tell me it went down to 19 or 18 days. You didn't do that because that would be going down too, not so? What you said to me is, listen sir, I observed that the number of men that are going to do this job is doubling, which is multiplied by 2. Therefore, because this is an inverse proportion problem, and you know that practically, this 20 is not only going to go down, it's going to go down in a particular ratio, and that is, it is going to be halved. So if this is double, then that is half. That's what you all told me. And that is an example of inverse proportion. And in that case, and in other cases of inverse proportion, when it is not so clear, like this, because it doesn't have to be clear. If I'd say 13 men, what are you going to do? You understand? Or something of a little more tricky nature, you'll have to have a formula, and this is the formula we're going to use. So I'm going to illustrate it by giving you a question. So the question is, write it. Question now. If 12 men can sew 180 shirts, if 12 men can sew 180 shirts in 5 days, how long will it take 15 men? How long will it take 15 men to sew? How long will it take 15 men to sew the 180 shirts? How long will it take to sew? How long will it take 15 men to sew the 180 shirts? Okay, so if you write down that information quickly, 12 men, they do a job, right? They do a job. And that job is to sew the 180 shirts. And they take 5 days. The question is asking you, if you put 15 men on that same job, which is to sew the 180 shirts, how long is it going to take you? That's what they're asking. 12 men do that particular job in 5 days, which is to sew the 180 shirts. How long will it take 15 men to do that job? Now, based on our conversation before, we know that this is inverse proportion. It is not direct proportion. Because you expect that when the number of men go up, the time to do the job wouldn't go up, it will go down. So that tells you it's inverse proportion. Otherwise, if the men went up, then the days would also go up. That would be direct. So it's indirect. And we know that seeing that it's indirect, seeing that it's indirect proportion, we could say that x1, y1 is equal to x2, y2. That's the equation that we just learned. And then you ask yourself, what is x1 and what is y1 and all that? Let's call this quantity x, and let's call this one y. Then obviously, the 12 men will be x1, right? The 5 days will be y1. The 15 men will be x2, and the unknown will be y2. So if we apply our formula, x1, y1 will be 12 multiplied by 5, and x2, y2 will be 15 multiplied by y2. So can we solve this equation? That's an easy one compared to all that we had to do. 12 by 5 is 60 is equal to 15 y2, and therefore 60 over 15 is equal to y2. So therefore 60 over 15 equal to y2, which is equal to 4, and is 4 days. So the answer would be 4 days. Practically, is that making sense? The number of men went up by a few. So the number of days is going to just go down slightly. It's going to go down to 4 days. Makes sense, right? Practically makes sense. So this is the solution that we would use for that. Okay, so this new section is, main heading is consumer arithmetic, and we'll first look at simple interest. Okay, so in order for us to do any simple interest problem, we will need to look at two equations. Right? The first equation, which is equation 1, is I is equal to P by R by T all over 100. And equation 2 will be A is equal to P plus I. Okay? What you may be asking yourself is what all of these things mean, right? And these things mean the following. I is the what? The interest. What's the next one? P. P is principal. What's the next one? R. R is the rate, percent per annum. What's the next one? T. T is the time in years. What's the next one? A. A is the amount accruing. A is the amount accruing. That's what these different things mean. A is the amount accruing. Okay? So, very quickly, if I take $1,000, and I put it into the bank, and the bank gives me a rate of 10%, right? Very quickly, you're doing it mentally. The $1,000 that I invest into the bank is known as my principal. That $1,000 will be my principal. That's what I'm putting into the bank. I'm investing. The 10% will be known as my rate. 10% is my rate. Now, after 1 year, that will be known as my time. I am going to gain some interest. And the interest I'm going to gain will be 10% of $1,000. And that interest will be how much? $100. You better know what they're giving you, you know. Right? So your interest is $100. So in that time frame, when I go back to the bank and I tell them, I would like to get my money, please, what they will give me? They will give me the amount accruing to me, which is known as A. And that will be equal to the principal plus the interest. So my amount accruing will be $1,100. When I add these two, I'm going to get that guy there, which is my amount accruing. So do you see practically what each one of those terms mean? I invest a principal of 1,000 at 10% rate per annum, interest per annum. I'm putting it for 1 year. So at the end of the year, I'll get 10% of $1,000, which is $100. And therefore, when I go to collect my money at the end of the year, I will receive an amount accruing A, which is equal to 1,000 plus 100, which is $1,100. Is that okay? Right, that's simple enough. So now, let's see something that's a little more involved. Write down this example. It says, Mr. Lord borrowed Mr. Lord borrowed $10,000 from a bank. Mr. Lord borrowed $10,000 from a bank at 8% per annum. At 8% per annum for 3 years. Mr. Lord borrowed $10,000 from a bank at 8% per annum for 3 years. A. What is the simple interest payable? A. What is the simple interest payable? B. Find the amount accruing for the loan. B. Find the amount accruing for the loan. C. Determine the sum of each monthly installment. Determine the sum of each monthly installment. Okay? So, look at that question. And somebody tell me what is the principle in this question? 10,000. In this case, you are not putting money into the bank. You are taking money out of the bank. You are borrowing money. Right? And if you're borrowing money, you're going to be charged interest on it. You have to pay them back that interest. Okay? So, we could write here certain things. We could write what the principle is. The principle we said was $10,000, correct? Good. What is the rate percent? How much, what is the percentage you have to pay back? 8%. So that means R is 8%. What's the time that you have to pay this back on? Over? 3 years. So T is 3 years. That's all the information they give you. In part A, what is the simple interest payable? Therefore, you have to find what I is. Do you think you can do that based on the equation set up here? I is P by R by T over 100. Work it out for me and tell me what you get. So if you check it back, you should find that the interest, which is what you're trying to find, is 10,000 multiplied by 8 multiplied by 3 all divided by 100. So even without the calculator, we could divide the top and bottom by 100 like that. And you'll have 100 by 8, which is 800. 800 by 3 is 2,400. And that will be in dollars. So the answer is $2,400. Could do that very quickly even without the calculator. Okay? Right, what about the second part? Find the amount accruing for the loan. In other words, what's the total amount that this person has to pay back? What's the total amount that this person has to pay back? Amount accruing is the principal plus the interest. And we know the principal was $10,000. And we know the interest was $2,400. So the total amount that this person has to pay back will be $12,400. So the answer is, for second part, is $12,400. The answer for the second part is $12,400. And part C now, that would have tended to be the trickiest part of all. which is the sum of each monthly installment. How will you do that? We say that the sum of each monthly installment could be obtained by finding the total amount accruing, which is how much the total you have to pay back, or he has to pay back, divided by the time that he has to pay it back in, which is the number of months in 3 years. Right, if you take a look at that equation, the sum of each monthly installment is, in other words, how much does he have to pay back every month? What you do is you take the total he has to pay back, which is this figure here, and divide by the total time he has to pay it back in months. Right? So what that is saying is that you'd have to take the figure of $12,400 that the total he has to pay back and divide it by 36 months. Because there are 12 months in a year, and over 3 years, that's 36 months. And when you divide that, you'll get the sum or the amount of money he has to pay back each month, which is known as his monthly installment. So that would work out to be, when you calculate that, $344.44. But this here is rounded off to the nearest cent. So you have to put in what you rounded off to. Right, that is rounded off to the nearest cent. Any questions with that? Okay, check it out. Next question. The simple interest on a sum of money, the simple interest on a sum of money invested for 6 months, the simple interest on a sum of money invested for 6 months at 5% per annum, at 5% per annum is $1,680. That's 1,680. The simple interest on a sum of money invested for 6 months at 5% per annum is $1,680. 1,680. Full stop. Find the amount of money invested. Find the amount of money invested. Okay, so in this question, could anybody tell me what's the principle? What's the principle in this question? Okay, the way that I ask the question, I put you under some pressure there psychologically. Right? If I'd asked it this way, did they give you the principle in this question? See if you'd answer it differently. Did they give you the principle in this question? Check it and see. If they're asking to find the amount of money invested, the question is find the amount of money invested. They're asking you to find the principle. Not so? So therefore they didn't give you the principle. Right? But the way I asked the question, it insinuated that they had asked you the principle. Okay? But what I expected somebody to say is, so they didn't give you the principle. Right? Okay. So, therefore, what is the 1680 in this question then? What is the 1680 in this question if it's not the principle? What is it? It is the interest. Because let me read it back for you and see if you can see definitely is the interest. Listen, the simple interest on a sum of money invested for 6 months at 5% per annum is 1680. So the simple interest is 1680. All right? And sometimes they construct it in that way to give you a little confusion. All right? But now you know the little tricks they're up to. So therefore, you could write that the simple interest is 1680. And once you could start to write down what the individual things are, then you could do the question. So you could write that the simple interest I is equal to 1680. What else do you know in this question? The rate. The rate. What is the rate in this question? 5%. What's the time? 6 months. So writing it down. Good. Anything else? They want us to find the amount of money invested. So they want us to find the principal. That is what they want us to find in this question. So what I'm teaching you now is a way to use just one equation to solve all of the different things. In other words, regardless of if they ask you for the principal, the rate, the time, or the interest, you're going to use the same equation. You're not going to have to learn 4 different ones. You're only going to use one. And let me show you how you use it. We're going to write in what we know. We know the interest. Let's just write it. Interest equal to principal by rate by time over 100. That's the equation we know. So let's substitute what we know into this equation. I is 1680, so we could write that here. The principal is unknown, so we just put back P. The rate is 5%. The time is 6 months over 100. Is that statement correct? Is that mathematical equation correct? Huh? No. You know why it's not correct? Because if you check back what time is the amount that the money is invested or taken out on a loan in what unit? Years. Is this 6 years? It's 6 months. So what do we have to do to convert it to years? Divide by 12, because there are 12 months in a year. So you make sure you have that under cover, and then you could go ahead. So then I could write 1680 would be equal to P times, and you could work this out. 6 into 6, 1. 6 into 12, 2. 5 multiplied by a half is really 2 and a half, or 2.5. And I have to divide that by 100. Now if you put the right-hand side there into your calculator, that is the part 2.5 divided by 100. You'll get 100. 2.5 divided by 100 will give you 0.025. Right? And then we know how to solve this. How we solve to get P is we're going to divide this side by 0.025 to eliminate it. And then we have to divide this side by 0.025. Normal, simple solving equation. So we divide this side by 0.025. And if we divide this side by it as well, we're going to get what P is. So your principal is 1680 over 0.025, which works out to be a figure of 67,000. If you put it in your calculator, 200. 67,200. Okay, so the little arithmetic here is what you would need to be familiar with. And in order to work that out, what I did was cancel out here, multiply the 5 by a half to get 2.5, and then the 2.5 divided by 100 is this. To work out this, we divide this side here by 0.025, which cancels it out to give me P, and I must also divide this side by it as well, which works out to be 67,200. 67,200. So that would be the principal. Okay, we have 2 more quick questions and we close off. Right. The simple interest on $8,500, the simple interest on $8,500 invested for 6.5 years the simple interest on $8,500 invested for 6.5 years is $3,867.50, which is 3867.50. 3867.50. That's dollars, right? The simple interest on $8,500 invested for 6.5 years is 3867.50 or $3,867.50. Full stop. Calculate the rate percent per annum. Calculate the rate percent per annum. Okay, somebody tell me what the interest is. So which one it is? Right, 3,867.50, because the simple interest on 8,500 so and so for 6.5 years is, so the simple interest in this question is 3,867.50 dollars. That is simple interest. Right? What else do we know? We also know the principal. Simple interest on 8,500. So we know that's the principal. Do we know the time? All right. Is that in the correct units? Yes, it's in years already. 6.5 years. We have to calculate what R is, the rate percent. So we go back to our equation. Simple interest I is principal by rate by time all over 100. So let's substitute. I is 3867.50. That'll be equal to the principal, which is 8,500, multiplied by the rate percent, which is unknown, multiplied by the time, which is 6.5 years, divided by 100. So how do we work that out now? How do we work that out now? I can multiply 8,500 by 6.5. That is okay. Because remember, multiplication, it doesn't matter which one you do first, second, or third. Good? It doesn't matter which one I multiply. So I'm going to multiply 8,500 by 6.5, and the result, I'm going to divide it by 100. And what you'll find, if you do it that way, is that you're going to get 552.5. If you take this, multiply by that, and divide by 100, you'll get 552.5, and I still have to multiply it by R, but I don't know the value of R, and that'll be equal to 3867.50. So you guys know by now, if I have something multiplied by what I want to get, all I have to do is divide by that. I divide by that on this side, I'll get R, and therefore I have to divide by it on this side as well. Good? And I'll work it out, and when you work out that, you'll get a nice round figure of 7%. So your answer for that one is R equal to 7%. Making some sense? A little bit? All right. That's good. Okay, so take it down. So each time you notice, regardless of if they ask for R, or they ask for T, or they ask for P, or they ask for I, we're only using one equation. How are we using it? We finding out what it is they gave us. We taking those values, putting it into the equation, And then whatever is missing, we solve in the equation for that quantity in each case. That is why it was important for us to study how to solve equations before, because we're using it over and over and over again. You observe that. Okay, and the last one we're doing for tonight is the simple interest on $5,400. The simple interest on $5,400 invested at 8.75%, invested at 8.75% per annum, is $1,890. Is $1,890. Determine the period of investment. Determine the period of investment. The simple interest on $5,400 invested at 8.75% per annum is $1,890. Determine the period of investment. Okay, what is the interest in this question? $1,890. What is the principal? $5,400. Good. What is the rate? 8.75% per annum. And what time? What's the time? That's unknown. That is what we have to find in this question. Do you think you could solve it? Make an attempt. Make one attempt. Start off by using the equation. Interest is equal to principal by rate by time over 100. And solve that. And tell me what you get for T. If we put the numbers in the equation, you'll get 5,400 here. You'll get 8.75 here. You'll get T being the unknown over 100. So your interest, therefore, if we work out the 5,400 by the 8.75 and then divide that answer by 100, right? Multiply these two and then divide it by the 100. You should get a figure of 472.5. Right? So you multiply these two, divide that answer by 100, you'll get 472.5, but you still have to multiply it by T. Good? But we learned from all the examples we did, even if you never solved an equation before, by now you should know that when you're faced with this, all you have to do is divide both sides by that number. In other words, when you divide this by 472.5, this will cancel and you'll just have T on that side when you divide it. And therefore, we have to divide the interest, which was 1890. I didn't write it in until now, but I could have. 1890 has to also be divided by that number, which is the 472.5. The interest was 1890, so we put it in, right? 1890. And therefore, when you divide it 2, you get T. And that works out to be 4, and it will be in years. So your answer is 4 years. Okay? 4 years. Okay, so that's where we'll close off for tonight. I've put the homework up on the board. And the homework here will be 30, exercise 30 and 31 to close off the ratio. 32, 33, and 51 will deal with percentage, with simple interest. Okay, 51 will deal with simple interest. So we close with that today.